Our last installment here of quadrilaterals. We're going to go through, we talked the last 2 days on parallelograms and special parallelograms, rhombus, squares, and rectangles. Today we're going to talk about special quadrilaterals that are not parallelograms. So we got a kite, we got trapezoids or an isosceles trapezoid, and you better believe it, isosceles trapezoid means one pair of sides are congruent. So we're going to roll through. Please jot down the properties. But a kite has two pairs of adjacent congruent sides. Its diagonals are perpendicular. And exactly one pair of opposite angles are congruent. Okay? So what does that mean? The sides, the adjacent sides, right, ones that are next to, there's two pairs that are congruent. So those two sides are next to each other. They're equal. These two are equal. And then where their sides meet, these angles would be congruent. And we got perpendicular. So that's the properties of a kite. And then with the trapezoid, I did the white highlighter or white pencil over the top of number 4 on the trapezoid. So you can do the same, but trapezoids have exactly one pair of parallel sides. We call those parallel sides the bases. And then non-parallel sides are called the legs. So we got bases. We talked about this when we talked area of a parallelogram. And then we got legs. If the trapezoid is isosceles, well, we know a couple things. We know the legs are congruent. We know that base angles are congruent. And then we have another pair up top because we have two bases. We know the diagonals are congruent. So in this case, CB is congruent to or the same length as AD. And then number 4, adjacent angles along the legs are supplementary. So angle A plus, and so adjacent next to, along the leg, so A and C. So angle A plus angle C, that measure has to equal 180 degrees. Same thing on the other side. D and B have to add to 180. All right, they're basically same side interior angles, much like we talked about for a parallelogram. So those are the properties. We get to apply them now. So again, I just uploaded the worksheet straight into notes. All right, so we got AC, diagonal, and BD, diagonal, and it tells us it's an isosceles trapezoid. Well, the diagonals in an isosceles trapezoid are congruent, so I'm going to take and set those two equal to each other. And then we solve, subtract 9x. 3x minus 11 equals -2. Add 11, 3x equals 9, x equals 3. All right, now we actually have to find the lengths, not just put 9x minus 2 in there. BD is 9 times 3 minus 2, which is 25. And hopefully we get the same exact thing. We got 12 times 3 is 36, minus 11 is 25. So that's the diagonals. Well, now they give us BE is 10. Well, E to D then, if B to D was 25, that means this is 15. Guess what? This is 10. This is 15 because the diagonals are going to be congruent. So D to E is 15. A to E is 15. C to E is 10. And then now we work with the angles. And so we got angle bad. BAD is 50. Well, if it's isosceles, we said base angles are congruent, so this is 50. And that's CDA or ADC. CDA is 50. ABC then, well, we said that the adjacent angles along a leg are supplementary. So 50 plus 130 has to equal 180. So angle ABC is 130. And same thing with DBC. Oh, DBC, I think that's a misprint here. DBC, it should be D. This should be measure of DCB. Would also be 130 degrees. Okay, so that's our isosceles trapezoid. Goes pretty quick. All right, ABCD is a kite. All right, so what do we know about kites? We know that they have two pairs of congruent sides. We know the diagonals are perpendicular. And we know that these two angles in the corners are going to be the same measure. All right, so if we know AB is 7, we also know AD is 7. If DC is 12, we know that BC is 12. All right, and then they sneak in there, BE is 5. We want to find out D to E. Well, guess what that's going to be? 5. Now, lots of congruent stuff. And then we got BEA. All right, so that's the sides. And notice how, and we didn't say, but this diagonal got cut in half. These two sides are congruent. So that's how we used 5 and 5. Okay, we didn't say that, but we're ready to rock with the angles now. ABC. ABC. So this whole thing right here is 84. All right, CDA. CDA is also 84 because those are the angles that are congruent. And then BEA. BEA is the one in the middle. We said those are perpendicular. That's going to get you 90 degrees. All right, let's rock with this kite. AD is congruent to AB. So I'm going to set those two equal to each other. Subtract 2, add 5. Subtract 2x and add 5. We get 2x is equal to 10. X is equal to 5. And that's going to make AD 2 times 5 plus 5, which is 15. And then this was 4 times 5 minus 5, which is 15. Those are the same. Okay, now we got to solve for y. BC and DC are congruent. So I want to set those two equal to each other. 3y plus 1 equals 4y minus 7. So I'm going to subtract 3y and add 7. We get 1y is equal to 8, so y is equal to 8, which makes BC 3 times 8 plus 1, which is 25. DC is 4 times 8, which is 32, minus 7, which is 25. Got to find Z. AEB is a 90-degree angle. So I'm going to take angle AEB at 7Z plus 13 is going to equal 90. Let me subtract 13. Divide by 7. Z is equal to 11. AEB then is going to be, well, we already know that's 90 degrees. But 7 times 11 is 77, plus 13 is 90. All right? And then we got ADC and ABC. Those are the congruent angles, so I can set those two equal to each other. So I'm going to do 12A plus 40 is equal to 20A. Subtract 12A. Divide by 8. A is equal to 5. And then now substitute those values in. Well, 20 times 5 is 100. And then 12 times 5 plus 40, so 60 plus 40 is 100 degrees. So those are the properties of a trapezoid and a kite. We'll get some more practice with them next week, and we'll be ready to go and end trimester 2.